Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the same book, Modern Physics by Paul A. Tipler. As usual, we first come to its statement. Okay. The wavelength of visible light range from about 380 nanometer, nano standing for 10 to power minus 9. Okay. 380 nanometer to about 750 nanometer. Nano standing for 10 to power minus 9. Part A. What is the range of photon energies in electron volt in visible light? Part B. A typical frequency modulation radio stations broadcast frequency. Okay, a typical frequency modulation radio stations broadcast frequency is about 100 megahertz. Dear students, mega standing for 10 to power 6 million, or mega meaning 10 to power 6, while hertz, unit of hertz is 1 over second. Okay, that is to say second and hertz are reciprocal of each other. Okay, what is the energy of an FM photon of that frequency? Okay, now we come to its solution, but before starting its solution in a formal manner, we will have to go through two snapshots. Okay, these snapshots will provide a foundation regarding the solution of our problem. Okay, first snapshot is about momentum of a photon. Okay, momentum of a photon P is equal to E over C, capital E over small c, where capital E is the photon energy while c is the speed of light in vacuum or vacuum. Okay, this expression alternatively becomes equal to hf over c, where h is the Planck's constant and f is the frequency, while c is the same as in the previous step, that is speed of light in vacuum. Then this expression alternatively in the third step, in the third stage, becomes equal to h over lambda, where h is Planck's constant and lambda is the wavelength. Okay, next snapshot is the table of physical constants, in which a large number of physical constants have been given. We will choose that physical constant which will be required for the purpose of solution of our problem. Okay, this table has been taken several times in our previous problems, mm, in our previous videos. Okay, so we will not give more time to this table of physical constants, and we skip its further explanation. Okay, further discussion. Okay, now we come towards the solution of part A. Okay, part A, momentum P is equal to E over C, is alternatively hf over c, and alternatively h equal to h over lambda. Okay, this expression has been taken from our first snapshot, which was about momentum of a photon. Okay, momentum of a photon P is equal to energy of photon capital E over small c, speed of light. This alternatively becomes equal to Planck's constant h into frequency f over speed of light c, and this alternatively becomes equal to Planck's constant h divided by wavelength lambda. Okay, dear students, we rearrange this expression as Energy of photon is equal to Planck's constant h into speed of light c over lambda. Okay, we have rearranged this expression in this form because we are concerned with this form of that expression. Okay, E equal to hc over lambda. We suppose that E over c is equal to h over lambda. E over c is equal to h over lambda. From here c will be shifted on other side equality and will be multiplied with this h, and hence E will become hc over lambda. Okay, dear students, in the table which we have shown as a second snapshot in our problem contains a large number of physical constants. Okay, in those large number of physical constants, one constant is Planck's constant h, and one constant is c, speed of light, and another constant is the combined result of these two constants, uh, that is speed of light into that is speed of light into Planck's constant h. Okay, so in that table separate value of Planck's constant h is also given, while separate value of speed of light c is also given, and combined value of hc is also given in that table. Okay, so from that table we have taken this combined value of hc, which is equal to 1240 electron volt into nanometer. Moreover, value of lambda is provided in the statement, which is 380 nanometer, nano standing for 10 to power minus 9, but here we will not use 10 to power 9 in place of nano because we have nothing to do with nano, because nano is cancelled here. Nano occurs not only in the numerator but also in the denominator, and hence nano will be cancelled with nano. Moreover, meter will be cancelled with meter. Okay, nanometer will be cancelled with nanometer, and hence our E will become equal to 3.2631 electron volt. We give equation number 1 to this result. Okay, now again we come to this E equal to hc over lambda. Here again combined value of hc has been taken from the table of physical constants, which has been included as a snapshot in this problem, and value of lambda is given in the statement. In this statement two values of lambda are given. Okay, because this is uh, giving a range of wavelengths. Okay, so first is 380, while range starts from 380 to 750. Okay, so in the first time we have used first wavelength, that is 380 nanometer, while in the second stage we are using other wavelength, that is 750 nanometer, and here again same happening will be done with this subsequent case, that is to say nanometer will be cancelled with nanometer, and our energy of photon will become equal to 1.6533 electron volt. We give equation number 2 this result. Okay, from 1 and 2, that is to say from equation 1 and 2, or from result 1 and 2, range of E in visible light is from 1.6533 electron volt to 3.2631 electron volt. Okay, dear students, actually this value has appeared in second stage, while this value has been obtained in the first step, but here we have reversed this arrangement because this is smaller value and this is greater value, and when we are talking about range, we speak from smaller to greater value, okay, so that the um, sequence remains. Okay, now part B, that part has also in H is E is equal to HF. This has also been taken from the same expression that was given in several alternate steps, alternate versions, equivalent formations. Okay, this and this expression was given in the first snapshot which has been included in our problem. Okay, so according to that snapshot, according to that expression regarding which expression was basically about the momentum of a photon, we have E equal to hf, where h is the Planck's constant and f is the frequency. Okay, dear students, in the table of physical constants which has been included in this problem as a snapshot, in which various physical constants have been given, in that table value of Planck's constant h is also given. Not only value of Planck's constant h is given in that table, rather this value of Planck's constant h has been given in two equivalent or two alternate systems of units. Okay, this value is given as electron volt second, and other value is given in other system of units. Okay, so value of Planck's constant 4.136 into 10 raised to the power minus 15 electron volt into second has been taken from the table of physical constants which has been included in a snapshot at number 2 serial at 2 second snapshot. Okay, first snapshot was about momentum of a photon, while second snapshot was about table of physical constants. And now f frequency, that is 100 million hertz or megahertz, is provided in the statement, and we have already described that mega stands for million or 10 raised to the power 6, while hertz is the reciprocal of second. Unit of hertz is second inverse or 1 over second. Okay, so dear students, E becomes equal to 4.136 into 10 raised to the power minus 15 electron volt into second into 100 into 10 raised to the power 6. 10 raised to the power 6 has been used as a replacement for capital M into hertz. Okay, and we have already described that hertz and second are reciprocal of each other. Hertz means second inverse or 1 over second. So here second and hertz will be cancelled out, and our energy E will become equal to 4.136 into 10 raised to the power minus 7 electron volt. Why 10 raised to the power minus 7? Because, dear students, here this 10 raised to the power minus 15 is being multiplied with 100 as well as with 10 raised to the power 6. So 100 and 10 raised to the power 6 will have a cumulative effect of 10 raised to the power 8. That is to say 10 raised to the power plus 8, while this is 10 raised to the power minus 15. So plus 8 will be added in minus 15, and hence our final result will appear as 10 raised to the power minus 7. Okay, minus 15 plus 8 is equal to minus 7. So our Answer, that is E energy has become finally equal to 4.136 into 10 raised to the power minus 7 electron volt. And this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.